Hi, I'm Johnny and I will talk about dynamic programming. Dynamic programming is referring to the strategy where you remember previous steps and in later calculations you can refer to these to avoid repeated calculation. It is especially useful for algorithms where later steps recursively build on previous steps and the final answer is recursively built on all series of previous steps. A classic and a simple example is how we can recursively build a Fibonacci series. For each of the indices, we recursively call the algorithm itself to calculate the previous two numbers, and then add them up. During the process, each number will be calculated multiple times, and to avoid the waste of time of calculating something we already know, we can use a global array or some kind of storage to put all the answers in there. And every time we come from one point to look for the previous index, we can just look into the array and depending on if there is a pre-calculated answer, we can just refer to that answer instead of calculating again. Therefore, the time complexity of calculating Fibonacci series can be shrinked into linear time and is more efficient. And from that example, we can see dynamic programming is not how we can get the correct answer. Say in the Fibonacci series, if we do not have a dynamic database or array, we just brute force through all the steps, you can still get the correct answer, say of a Fibonacci series of length 8, but it's significantly slower. Therefore, this is where dynamic programming kicks in. It's a efficient optimization of such recursive and repetitive algorithms. And in more sophisticated problems, it actually is enabling the algorithm to brute force through a whole multi-dimensional search space repeatedly while remaining a single pass time complexity. I will demonstrate this point by this example. It is the number 72 from LeetCode. Given two words, word 1 and word 2, find the minimum number of operations to convert word 1 to word 2. Basically, it's asking for optimization of a series of operations selecting from insertion, deletion, and substitution or replace to convert one list to another. Those are performed on list elements, of course. To approach this problem, my answer builds a two-dimensional search space, which is each point in the search space, or is actually a 2D grid. Each point in the grid corresponds to the solution of the same problem, but just word 1 is the first, say, n characters from word 1 itself, and word 2 is the first characters, and each one of the elements is calculated depending on the three previous steps, from which this current step can be calculated or can be generated through addition, deletion, or substitution. For example, if I have a point at mn, and I want to refer to the solution at mn minus 1, where m minus 1 refers to the length of the second substring. It means from the previous solution, I just need to add one insertion operation to get to a solution for mn. And from the three potential or possible previous steps, the algorithm will select the smallest one from them and then add the required operations to it to get to the current location. It can be 1 if it's just addition or deletion or substitution from one character to a different character, or it can be 0 if it's substitution from one character to itself. That is, the case of common substring is taken care of by this algorithm. The problem with this algorithm is that it's not a, say, n times m time complexity, because it's every step always depends on the previous steps, and it's actually way beyond just n times m. But using a 2D array to remember each calculated substep, we can actually shrink the time complexity to just the size of this 2D search space, because for each element, the solution doesn't depend on which other procedure caused it. Once it's calculated, it will remain unchanged. Therefore, we can just remember this solution, and for later calculations, just refer to the corresponding element to a 2D array or hash map. Therefore, the time complexity of this solution is greatly optimized, and we can calculate this problem without doing further changes to to the idea, or just using this simple algorithm.